Okay, for this question, mu is given as 24,000 km, and then standard deviation is given as 2,500 km. Okay, very first thing that you have to do, draw a bell curve and then sketch so that you can imagine where it's going to be. Okay, where the value is going to be. The first question, what percentage of tires, such tires, will need replacing before they have traveled 20,000 km? Okay, so the mu is 24 km and the SD is 2500 km. So 20,000. Okay, so since it's the standard deviation is 2,500, so if you add one more standard deviation, you will have 26,500 over here, and then another 2,500 will give us 29,000. 29,000 exactly over here. So that's two standard deviation, and over here one standard deviation will give us minus 25, which is 21,500 km, and then 19,000 km. Okay, so if it's 20,000, so this is 2,000, 21,000, so 20,000 should be somewhere here maybe. Okay, roughly. Okay, 20,000. So find the z score, and then the rest is okay, same method. Okay, find the z score. Okay, so z score, I'm not sure, but I know it's 20,000 x minus mu, which is 24,000, over standard deviation 2500, and looks like it's a negative value, and the answer is negative 1.6. Now go to the standard deviation, normal distribution table. Okay, so I always use the MF19 table to make things easy, because that's the table that you will be getting as well. So just make sure you get used to with that. So using that table, the value that I've got is, okay, so phi of okay, excuse me, phi of 1.6 is 0.9452. Okay, so 0.9452 is the area towards the left side, but that's not what I want. I want this blue color region. Okay, a small region. It's not 94.5%, so all you have to do 1 minus 0.9452, and the answer that I have here is 0.0548, which is 5.48%. Okay, next question. As a result of improvement in manufacture, the length of life is still normally distributed, but the proportion of the tire failing before is reduced to 1.5. Okay, reduced to 1.5. So let's do this. Question 2, reduced to 1.5%. Okay, so 1.5 is 0.015, and if you look at this table, okay, 0.015 is again a very small percentage, which is somewhere at the tail end over here. Okay, at the tail end over here. So again, it's going to be a negative z value. Okay, so what I'm going to do is I'm going to minus 1 minus 0.015, and this gave us 0.985. so use your distribution table, normal distribution table, to find out what is the value. Okay, the value that I have here for 0.985 is 2.17, but since it's not, we are not looking at 0.985, we are looking at 0.015, so you change the phi of, okay, negative phi, sorry, it's not negative phi, excuse me. So the answer, oops, so your z score that I'm getting here is 2.17, and since it's on the left side, it should be negative 2.17. So z is negative 2.17. Excuse me. Okay, negative 2.17. So that's your z score. So once you got your z score, you can sub this into your formula and find what is the mu. Okay, so to find mu, z equals to x minus mu over standard deviation, and z here is negative 2.17 equals to x, which is 20,000, that doesn't change, and then mu over 2,500. So 2,500 times by negative 2.17 equals to 20,000 minus mu, and then mu equals to 20,000. Okay, negative 2.17 times 2500 is 5425. So your standard deviation, sorry, mu is, the mean is 25425. Okay, next part B. If instead the mean length of life has remained unchanged, okay, mean length of life remain unchanged, calculate the new standard deviation. Okay, this time you just have to find the standard deviation. So the mean life doesn't change, it's still 1.5, okay, being reduced to 1.5. So I'm going to use the same z score because of 1.5. For that we got negative 2.17. So part B, okay, so negative 2.17, that remains the same, and then your mean is 20, your lifetime is 20,000, and then minus your mean, which is 24,000, and then divide this by your standard deviation. So that's what I have to find, what is our standard deviation. So using this, okay, values, so 20,000 minus 24,000 is 4,000, divide by negative 2.17. Okay, and the answer that I have is 1843. Okay.